Dalrymple, and Tom's back with us. So I invite James to come. James Dalrymple is the Business Development Manager for Greenblue and has been part of the Greenblue urban team since the early 90s. As a director, he's been involved with many advances in successful urban tree planting technology. Today, he will be speaking about sustainable stormwater management and the urban environment. So, James, thank you.
How do we get this to work? There we go. Brilliant. Well, a very good afternoon to you all. I'm not going to attempt to say good afternoon in Welsh. Kudos to those who have done earlier in the day. I'm actually live and work in Shrewsbury, which is very close to the Welsh border, but I'm not Welsh. But it's yeah, really cool to be here today. So yeah, just very briefly about myself. I've been with a company called Greenblue Urban since November 1999, so that will be 25 years this year. Greenblue Urban, we are very much a UK business. Quite a lot of what we sell outside of the UK. So we've got a network of wholesalers across Europe. We sell a lot and we manufacture it in the Middle East. We've got a couple of teams on the ground in North America too. So we've had a lot of experience over the years of getting trees established in different climates and in very challenging different areas. Now, we just call this a holistic approach because there's a huge amount of change happening across the industry, particularly with, well, you guys will be very familiar with Schedule 3, which has already been implemented in Wales, which there was talk of coming to England later this year, but I don't think it's going to happen. But whatever, people are seriously thinking about it. And of course, there's all the mandatory BNG stuff. So how we manage surface water and our landscape features, particularly on new development sites, is really important that we get lots and lots of different parties involved. Now, often landscape designers and master planners, well, particularly when you get into detailed landscape design, they get brought in potentially towards the end of a scheme, which is a great shame because how we manage surface water and how we manage it in conjunction with the landscape is just very, very much tied together. So we say that we operate as the interface between nature and the built environment. Now, I love it when we see master plans with lots of frozen peas all over them, which one day hopefully will become big mature trees. But nobody's really given a second thought to what that tree needs to grow or how it needs to grow or its longevity. Unfortunately, quite a few of the London boroughs seem to be particularly guilty of this. They get obsessed with tree quantities. They have it is politically driven largely, and they have to plant, I don't know, 10,000 trees in 2 years or 3 years. Now, what they're doing, if they just lift up a paving slab and pop a tree in, they are creating a massive liability for future generations. It's much, much better to plant to a much higher standard because the environmental benefits come with canopy cover, not with lots of dead trees. So I'm sure a lot of you will be very familiar with the Syria SUDS manual. And again, if anybody's read it from cover to cover, fair play to them, because it's a document that's nearly 1,000 pages long. But integral to the document is what we call these 4 pillars. Now, I've just shown this here briefly because a lot of what drainage engineers have specified traditionally, which is gullies and pipes and possibly ponds and tanks, actually deal with those first 2 points, quantity and quality, quite well. But once you get water underground, you don't really pick up these biodiversity and amenity benefits, which are so critical. So just 1 or 2 myths. Now, I'm just going to miss that top point because we've had some really good stuff about ponds this morning. So I'm just going to say it's a myth that below ground tanks are required, that SUDS is expensive and that it takes up a lot of land. Now, just regarding the ponds, there's loads and loads of good stuff associated with ponds. However, on some development sites, when you're really wanting to max out on units, if you can capture the water where it lands, which is what we generally term as source control, and we've got the ability, which I'll touch on in a minute, to model these interventions really carefully, it sometimes means that a big bomb crater or a huge buried tank can be reduced in size significantly. And we had a developer recently in Suffolk who redesigned their drainage scheme, and they came on to us saying, we've actually achieved 20% extra units. So they were very much better off. So a couple of little illustrations there. We've got the old problem and the old solution, which is potentially an oversized pipe, whereas the new solution is really carefully managing the surface water, maybe around, for example, a tree pit. So a lot of you probably are aware that to get a tree to grow in an urban environment, a tree needs lots of good quality uncompacted soil. Now, a lot of people don't know how much, and there's some brilliant formulas, which I won't go into too much detail now, but typically a tree might need anything from 15, 20, 25 cubic meters of soil, which is huge. That's a big hole. So to do that, we pioneered what we call the structural soil cell back in 2001. And we developed it. In principle, it's not unsimilar to an attenuation crate. You just simply fill it with soil. It's very, very strong structurally. You put an aeration deck over the top, and then you can build a road or a car park or a pavement. And what it does is it preserves the integrity of that soil, so it prevents it becoming compacted and keeps it very well aerated. And of course, what we realized a decade or more ago now is that that profile is also an ideal profile to pass surface water through. There's loads of void space. Soil is brilliant at cleaning water. It massively slows the runoff down, and of course the tree benefits every time it rains because it gets a drink, particularly in the summer months. And of course, as we know, in the summer months, trees will actually use up quite a lot of water. It's difficult to quantify because loads and loads of variables, so often again it doesn't go into modelling data, but we've done some testing of how much water trees can use, and even fairly newly planted trees can use 8 to 10,000 of litres of water per year. So just a couple of illustrations there. We've got a little stand next door. If you guys want any more detail about this stuff, please come and have a chat afterwards. So, and we also do a plug-and-play rain garden system, which is just very simply, it's designed to take sheet runoff off, again, a paved area, or if you're close to a building, you can drop a channel into it off a roof. One thing I would say is, if we're deliberately taking a given catchment area towards one of these green interventions, I cannot overemphasize enough the importance of the soil specification. The reason I say that is we've had some quite interesting experience where soil has gone wrong, and it's cost us an awful lot of money to put it right. So soil specification is key. If you use the wrong soil, you can spend a lot of money on these interventions and they simply won't work. So I also thought I'd touch on just working around underground constraints, because obviously I mentioned about these big excavations which we need to plant our trees, and then we backfill and nobody knows it's there once it's all installed. But very often we come across lots of competition with other utilities. Now, I would say is that just forward planning is brilliant. So if we can get as much mapping data as we possibly can, we can often design around them, to one side, underneath, above. But these situations, worst case scenario, we actually run them straight through. Strongly recommend that you engage with the utility provider. However, I would say it's not infrequent for these sort of situations to happen, and the contractor has just got 2 days to plant his tree. So it's all installed and the utility provider is none the wiser. Now, I'm not too concerned about that because tree roots don't have diamond tips on the end. They're good drilling holes in things, and they'll very happily coexist around, an awful lot of ducting. They'll get into a broken clay pipe and cause absolute mayhem, but a lot of modern pressure-tested utilities, they'll never ever cause a problem to. This is quite a fun fact. For every 5% of tree cover, stormwater runoff is reduced by 2%. Now, that needs more research, absolutely without question, because there's so many different types of tree, and a lot of canopy cover is held while the tree is in leaf. So a deciduous tree, you get very different performance during the winter months. But I don't know if you guys have ever been to St. Peter's Square in Manchester. It's one of the finest tree-covered squares, I think, in the UK. It's got enormous Paulonia tomentosa trees, which are foxglove trees with huge leaves about the size of an A4 piece of paper. If you go there during a really sharp storm, you'll just get these wonderful rain shadows, so zones of dry ground underneath the canopy, and everybody runs underneath the trees for cover, and you just see a few wet footprints and lines from pushchairs and whatnot, but it stays bone dry, and the water that's landed on that canopy never ever reaches the surface. And there's a bit of research on this, which what we're putting here. It's significant, but it's not an easy one to model. So a handful of case studies. This is Goldhawk Road in London. This was planted in 2015. Really forward-thinking scheme, this one. Taking quite a sizable catchment off the main road. A lot of design and planning, a lot of interaction with utilities. You can see the structural soil cells going in there over on the right-hand side. So once it's installed, most people just walk past that without even realising. However, if you're aware of what's going on and you happen to be down there when it's raining hard, it is fascinating to see this water just disappearing into a curb inlet, and you know fine well that that is being really well filtered. It's watering the tree. In some situations, it'll be infiltrating back into the ground. I don't think it was here. But it's massively taking the peak off our sharp storms by slowing the water down. This is another really interesting one. This is what I call a textbook SUDS project in Keighley, just outside of Bradford. This is our more modern soil cell, which we call the root space. Now, the contractor was a bit eager on this. On the right-hand side, he popped all the lids on without putting the soil in. So you'd have the gravel drainage layer at the base, then you install the system, fill it with soil, then you put the lids on, and then you have the layer works, obviously up to your wearing course above that. So you can see the metre square apertures where the trees are going to be planted, so it's always beneficial to link tree pits up where we can, because they can share rooting volume. But the interesting thing about this is that there's several hundred square metres of a reasonably major town centre road. There's 3 lanes of traffic coming towards us. There's traffic lights, there's vehicles braking and ticking over and shooting off again. And you can see the gaps in the curb where the water's running in. There's obviously silt being washed in off the road. The weeds are sort of thriving on it. And maintenance is shocking. Those trees were planted in 2017, and I don't think any of it been back there once. We pop back there quite regularly because it's a really important project for us. But there's just a line of 6 trees. So Yorkshire Water are chuffed to bits. They've got a whole chunk of catchment taken out of their combined system. Those trees are growing like the clappers, faster even than if in a tree nursery. And all the benefits that trees bring: biodiversity, shade, reduction in wind speed. At this point, quite a few people say, well, what about all the build-up of contaminants going to those tree pits? There's some guidance in the Serious SUDS manual that you ought to whip all this out and replace it every 25 years. Now, to me, without putting too fine a point on it, that is absolute nonsense. But it's all very well me saying that. Where's the evidence? So we did a lot of work begging for funding a year or so ago. Didn't get anywhere, so we funded it ourselves. MMU, Manchester Metropolitan University, have done a really in-depth study of the soil surrounding those trees. So they've taken core samples at the front and at the back and both sides of each tree, and they've taken them away to analyse them for their physical, chemical, microbiological properties. There is a report that's going to be released, and it's pretty in-depth, hopefully in the next month or so, and I've seen it, and it's fascinating. The vast majority of the nasties are kept right up near the surface. So, yeah, look out for that one. So that's just the same project from the other side. This is an interesting one. A lot of you guys will be very familiar with the Greener Grangetown project in Cardiff. We were very involved from early design stage on this one. For those of you who are not familiar with it, it's a sizable catchment. I think it's about 14 streets which back onto the River Taff. And prior to this work happening, it's a back-to-back Victorian housing, so very little chance for any water getting into the ground. All rushes off into the combined system, polluting the Taff. It's having to be pumped about 9 miles to the nearest treatment works. So we looked at a heavy engineering solution, bigger pipes, bigger pumps, 30-odd million quid. And then we sat down and really thought, loads of liaison with the residents, absolutely critical on retrofit SUDS, get them on board. And we came up with a much, I'll say simpler, a completely different design scheme, which costed about a tenth. It was about 4 million by the time it had gone in. And what we've done is we very carefully designed these little build-outs in most of the roads. The tree pit extends out underneath the paving areas. So those trees, although there's a little small area because parking's at a premium, the actual soil volume available for the tree is much bigger, about 8 to 10 cubic metres. And this scheme just works a treat. You get a heavy storm, about 80% of the catchment that was going into the combined system is completely removed. They've got to keep a little bit in, I think, to keep the brickhead sewers cleansed to some degree. And this water is discharged straight into the Taff. And it's now, the water that's going into the Taff is now very much cleaner than the water's running down the Taff. And it's going out at a very controlled rate. He's completely transformed the area visually. Aesthetically, it looks incredible. The property prices jumped 15% after the project was done. So it's an absolute win-win situation. So that's just one of the other streets. I've often thought if you're a savvy investor and you knew where a scheme like this was coming up, you'd buy up half a dozen houses and make a few quid. Right, we touched on the hydroplanter. There's 1 or 2 variations we do this, which I'm not going to go into too much detail now. One of them is the max, where we max out on the storage space where the lower half is voided. Again, just to reiterate, very quick, easy, simple to install. and we can actually model the hydraulic performance of this, because if you guys are very familiar with infra drainage, we've teamed up with a small team of very clever infra drainage modelers, and over the next few weeks we'll be releasing some very detailed instructions on how you can actually model these various elements. So the hydro plant is great when you've got nice linear straight lines. If you want to create radiuses or fancy shaped rain gardens, we just do a product which is a suite of products which we call the Flex, which in principle is very similar. You just do different areas. And one of our latest products we've produced is what we call the SUDS pod. Now, we don't take credit for the design of this because it was actually invented by a very clever chap up in Scotland, and about 4 or 5 years ago, and he got a guy doing his PhD to do a lot of modelling work on it. But he couldn't get anybody in the industry, A, to make it for him or to sort of take it seriously. But he came to our 30-year anniversary event a couple of years ago and said, I've never ever met a company with so much passion for combining green infrastructure and SUDS. So we looked into what he'd produced, and it was actually really clever. So it's very different to just a box with plants in it. It consists of a planter box on the top, so it looks really nice plants growing in it. But there's 3 chambers in it. So over on the right-hand side, that's the first chamber with a built-in silt trap. And then there's a vertical partition with little flow control orifices, which have been optimized for a 50 to 60 square meter catchment and storm events up to 1 in 30. So the water then flows into the first chamber, flows through the hole into the big second chamber, and then right at the far opposite side where the outlet is, there's another small chamber with a very similar pattern of orifice holes. And at the very top of that last chamber, there's a little weir for the exceedance route. So if we had a catastrophic storm, I'm talking where water's spilling over top in gutters and whatnot, it would never actually overflow, it would just exceed. So the way this works is quite different to a water butt. Water butts are great, but when they're full, they're not very great, because I mean, you've got some stored water, but they don't do anything for slowing down the flow. But what this does is it gradually drains all the way through the duration of the storm and for a few hours afterwards. So we've done loads of different storm scenarios, and there was one particular storm scenario which is quite long. I think it was a 1 in 5, 24 hour from memory. And we measured, the water got almost to the exceedance point, but not quite, and then slowly back down again. Now we measured the volume of water that had come out at a controlled rate of between 0 and 0.8 litres a second, and it was actually over 5 times the volume of the unit itself. Now that's, some people say, well, how can it tend to make more than its own volume? Because it's draining down very shortly after the storm starts and continues draining down for a couple of hours, or maybe 2 or 3 hours afterwards, you're getting a very, very controlled flow rate. So we've had a lot of interest from the water companies. We've got some quite interesting brochures next door, and it shows on the hydrograph we have the peak flow of water hitting the roof, and then a very similar graph of it actually entering the system, and then a really protracted long outlet. So if there's a CSO hotspot where there's, I don't know, 500 houses which are really making the problem worse, if you were to fit these sort of units to all those houses, we could actually model what the difference is. And we can model the difference between the various storm scenarios. And I've got an example of a little small one. I think we just did it on 5 houses. And once you get up to sort of 1 in 30, the percentage improvement drops quite significantly. It's not designed for the 1 in 100. It's designed for the vast majority of the much smaller events. This is in the Lake District where United Utilities actually provided some for the residents up there. So I just thought I'd show this one. Some of you might be familiar with Mould Town Centre. In the town centre of Mould is a very big car park, and they've had issues with flooding because it sort of flows in 2 directions and ends up down at one corner. I think the problem is a problem further downstream. But they've built a little flood wall in the bottom corner, which is just at the very bottom of the, you just about make out the mud mark actually if you go onto Google Maps. But they put a little like a right-angled flood wall because there's properties immediately behind. But just a few months ago, the water came within about 1 inch of overtopping. As we know, we're always going to get more severe storms, so they have got, it needs dealing with. So we did some simple modelling. We popped 8 trees across the car park. They're quite big excavations, and we're putting a permeable paving over the top of them, but we're not losing any car parking spaces. And just a few metres of our hydroplanter. And Yeah, sorry, the wording underneath that plan is not very clear. But in a 1 in 100 year storm, the flow rate is about 105 litres a second coming off that car park. By putting these interventions in, we've managed to reduce it to about 6.5. So it's a massive betterment. So if you've got, my point is, if you've got existing large areas of hard standing which are contributing towards downstream flooding, there's stuff we can easily do with it. So that's just a couple of cross sections of the tree pit itself. There's a flow control chamber associated with that. You wouldn't need one of those after each tree, just after each run. So I think there's about 5 runs in the car park. So just a tiny bit more about Greenblue. A lot of what we manufacture, and we've got our own in-house manufacturing facility, is either composite or plastic materials. Now, I know a lot's come in about plastic pollution and whatnot. Everything that we manufacture is 100% recycled. It's 100% recyclable again. We even offer the materials out of a marine waste. In fact, some of you might be familiar with the Churchill Way project in Cardiff, where they've opened up an old dock feeder. Really, really lovely project. And they specified all our roots-based system, which was manufactured from marine waste. So the circular economy, where we're keeping plastics out of landfill, out of the oceans, we're burying it underground, out of sight. Our trees are going to get massive. We're going to have a completely carbon neutral installation. So that's me. Thank you all very much.